Yes, sir. Thank you.
Okay. So we are done with question number 4B2, and we have to start from question number B43, B part 3. Okay. So let's start. Complete figure 4.2 to show the arrangement of electrons in bromine atom using the electron boxes in notation. So first, what you need to do, you have to look for the bromine's atomic number, and if you will find, I think if I recall, its atomic number is 35. Can anyone confirm me from the periodic table?
Yes, sir. 35.
So it means there are 35 electrons. Okay. And if you write the electronic configuration for these 35 electrons, it would be 1s2, 2s2, 2p6. There are 10 electrons over here. Then 3s2, three p6, 4s2, 20 electrons are filled. Then we have 3d10, 30 electrons are filled, and after 3d10 we have a 4p. So 5 electrons are filled in 4p5. So see, there are 30 electrons, and here they have mentioned argon, which means they have, mentioned that this electronic configuration is for argon over here. So we have to refill or fill these orbitals only. So what I am observing, that there are 10 electrons in 3D. So I'm going to fill 10 electrons, 1, 2, 3, 5. Okay. So we have to fill. Remember, whenever you are filling the orbitals which are of a same subshell, then those orbitals are actually, first filled unpaired, then you have to make the pairs. So after the fifth one, 6, 7, 8, 9, 10. So see, these 10 electrons are filled. Now we have a 4s. How many electrons are there? 2. So a pair over here. Then we have in 4p, there are 5 electrons. Yes, is anybody asking something? 1, 2, 3, 4, and 5. So this is how you fill the orbitals with electrons. Is this clear to everyone?
सर
Yes.
सर इसमें तो अभी अच्छे खासे फिल करने को थे, बट फर्ज करें अगर हमें कोई 5 इलेक्ट्रॉन्स फिल करने होते हैं तो मतलब पहले हम 4s वाला फिल करते हैं या 3d वाला फिल करते हैं?
See, when we write the electronic configuration, first you will write 4s.
जी.
So first you will fill the electrons of the 4 in the 4s and then in the 3d.
सही है.
So let me write the filling order of the electrons. So filling order would be first 1s, then 2s, then 2p, then 3s, then 3p. After 3p you will fill 4s, and after 4s you will fill 3d, and after 3d you will fill 4p. Okay.
सही है.
Now X is an addition polymer, and here they have shown you in the figure 4.3 the repeat unit of the X, and what they are asking, draw the monomer of the X. So if I make it in the structural form, so I can see that there is a 2 carbon, and these 2 carbon have a bonds which are going out of the brackets, and the carbon on the left having a 2 hydrogen on it, and the carbon atom on the right having a hydrogen, and then CH2, and then Cl, right? So if you have to make the monomer, what you will do? You will make those 2 carbons in the center with a double bond. Now on the carbon which is on the left of the double bond, put 2 hydrogens, and the carbon which is on the right of the double bond, a hydrogen on one side, and on the other side you will write CH2Cl. And if you have to show it in the skeletal form, you can write it a double bond, then 1 carbon, and then here there is a Cl. Is this understandable to everyone? If anyone have any doubt, first.
सब यूनिट होता है उसमें भी हमें डबल बॉन्ड शो करनी होती है या नहीं?
No, for repeat unit there is no need to show the double bond. In monomer the double bond is always shown. Okay, monomer,
जी सर.
the double bond is must. Okay, and for repeat unit, for example, if examiner asks you to write the repeat unit, so for repeat unit, no double bond. Okay.
सर skeletal और display दोनों acceptable है ना?
Yes, because they have shown, just wrote that draw the monomer of. They didn't mention that which monomer you have to draw or which type of the formula you have to represent. So there is no need to be specified. You can draw it in either way. Okay.
Repeat unit किसकी बात करते हैं समझ नहीं आ रहा.
For example.
सर इन्होंने दिया हुआ है ना repeat unit.
Yeah. For example, instead of that, in the question, the examiner have given you this thing. Let's suppose. Okay. And then examiner asks you that, for example, draw one repeat unit of the polymer shown above. Okay. So here in this case, you have to show these 2 carbons, then a chlorine over here, then empty bond over here, and an empty bond over here, like this only. That's it. So whenever you have to show the repeat unit, you don't make a double bond between the carbon atoms. That's what I have mentioned over here.
और सिर्फ 3 भी नहीं लिखेंगे, 3 दफा ऐसा हो रहा है.
Sorry?
यहाँ पे साइड पे n में नंबर नहीं लिखेंगे, नंबर ऑफ रिपीट, मतलब कितनी बार रिपीट हो रहा है.
No, because examiner asks you to draw one repeat unit. For example, if instead this examiner asks you to draw 3 repeat unit, you would repeat it 3 times, but don't write the n. N is written when you have to show the equation.
सर हमें ब्रैकेट्स कहाँ लगाने होते हैं? मोनोमर में ब्रैकेट्स लगाने होते हैं?
No, monomer is a single molecule, so there is no need to put the brackets in the monomer, and there is no empty bonds in the monomer. But in the repeat unit, you can show it without the brackets as well. But for example, if you are drawing like this without the skeletal formula, then you would write it like this. Then here you have shown the empty bonds on both the sides, so there is no need to put the brackets on the sides. You can do it just by drawing this only as well, so it is also fine. But in repeat unit, the empty bonds must be shown. Is this clear?
सर रिपीट यूनिट भी उसी टाइप ऑफ फॉर्मूला से बनाएंगे जिस टाइप ऑफ फॉर्मूला से उन्होंने लिखा हुआ है क्वेश्चन में, या फिर किसी
No.
भी टाइप ऑफ
No,
फॉर्मूला से?
it doesn't matter unless examiner specify you to draw the structural formula of the repeat unit, or to draw the displayed formula of the repeat unit, or draw the skeletal formula of the repeat unit. Otherwise, you can draw it in any manner. Okay.
ठीक है सर.
Now, suggest one reason why the disposal of items made from X is difficult.
Non-biodegradable.
Non-biodegradable. Okay. Okay. Beside non-biodegradable, that can we write any other reason beside this?
Toxic gas released if burned.
Yeah, on burning, toxic gas released. Good. So because there is a chlorine, so when we burn it, toxic gases are released. So it can be an answer as well. Okay. Now, here we are starting question number 5. Okay, this is A part. So we are going to start with question number 5. 3 reactions of 2-bromopropane, okay, are shown. In reaction 1, if you see, what you are observing that bromine is turning into an OH. Okay, so if you recall the reagent for this reaction, we normally use sodium hydroxide aqueous, and what we do, the conditions are heating or reflux for this reaction 1. Is this clear? And if we go for the, the type of the reaction, to see the bromine is replaced by OH. So when the bond is broken, it turns into bromide ion, and when the OH comes, it comes as a hydroxide ion. So a nucleophilic is substituting the other nucleophilic. So we consider this reaction a nucleophilic substitution reaction, SN reaction. Is this clear to everyone?
Yes sir.
Now, if you see in reaction 2, Br is replaced by NH2. So this is also a nucleophilic substitution reaction. Okay. This one is also a nucleophilic substitution reaction. And
Sir,
yes.
न्यूक्लियोफिलिक और इलेक्ट्रोफिलिक में मतलब सब्स्टिट्यूशन में डिफरेंशिएट कैसे करते हैं?
Remember, in AS level, the substitutions are, there are 2 substitutions, either nucleophilic or free radical. There is no electrophilic substitution in AS level. Okay.
अच्छा.
So if one group is substituting the other group and that group is not a carbon bonded to a hydrogen, then it is always a nucleophilic substitution. That is a shortcut way of remembering this.
सही.
That if this hydrogen, whatever the structure it have, if this hydrogen is, is replaced by any halogen, then that is considered as a free radical substitution. And if you are not observing any change in both of the structure, but you are observing this change, that the carbon hydrogen bond is in the reactant, and that instead of that carbon hydrogen bond, there is a carbon and a halogen bond, then that is a free radical substitution. Okay.
सही है.
But if carbon is bonded to any other group, and that any other group is actually replaced by any other group, then that is always a nucleophilic substitution in AS level. There is no other substitution. Okay.
सही है.
So for this reaction, we normally use ammonia, and that ammonia is in ethanolic solution, and the condition is heat under pressure. I think I have shared the spider diagrams. You can go over those while doing the organic past papers, especially the reaction ones. It will help you a lot initially. Now, in reaction 3, what you are observing that this is a alkyl halide or a halogenoalkane, right? And that alkyl halide or a halogenoalkane is actually turning into an alkene. So if you look closely, what you are going to find that there is this bromine atom over here, and there is a 3 hydrogens over here. Now in the product side, if you see, out of these 3 hydrogens, there are 2 hydrogens and there is a no bromine over here, and instead we have a double bond. So it is clearly indicating that in this reaction, yes, very good, Hamad, a hydrogen bromide is removed. So if a hydrogen bromide is removed, then this reaction is an elimination reaction because there are 2 atoms. Yeah, very good, Hamad. From the neighboring carbon are removed, and as a result, those 2 neighboring carbons form a pi bond or a double bond with each other. Is this understandable to everyone? Yes.
Yes,
And if you
sir.
recall, the reagent for this reaction, we use sodium hydroxide in ethanol, or ethanolic sodium hydroxide must be used for this reaction. Okay, and beside this, we have to heat the reaction mixture. So we have completed our homework. Now let's move to the part. Okay, so what they have asking, stating the reagents and conditions used, identifying the type of the reaction that occur. So we have identified the types of the reaction. In reaction 1 and reaction 2, both are nucleophilic substitution, right? If anyone have any confusion or doubt, do ask, please.
सही जो
So this-
एडिशन में न्यूक्लियोफिलिक और इलेक्ट्रोफिलिक होता है उसमें कैसे डिफरेंशिएट करते हैं?
If alkene is undergoing a addition, which means a carbon-carbon double bond turns into a carbon-carbon single bond, then it's an electrophilic addition. If a C double bond of an aldehyde or a ketone is converting into a C and a oxygen single bond, then it is a nucleophilic addition.
सही है, एल्डिहाइड और कीटोन में कार्बोनिल में न्यूक्लियोफिलिक होगा और एल्कीन में इलेक्ट्रोफिलिक होगा.
Yes, alkenes undergo electrophilic addition and carbonyls undergo nucleophilic addition. So the first 2 are nucleophilic substitutions because we are observing in the reaction 1 a halogen is replaced by OH, and in the second reaction a halogen is replaced by NH2. Okay.
सर ये
So-
सामने हीट लिख रहा है, तो ये हीट एंड रिफ्लेक्स हम पूरा लिखे या सिर्फ हीट?
Yeah, you can write heat under reflex as well, or you just write heat. Both are considered correct. Heat under reflex is a very important condition when we are doing the oxidation. It is when we are converting an alcohol into a carboxylic acid or an alcohol into a ketone, then there must be, you have to write heat under reflex. So in reaction 3, the reaction is elimination. Now, reagents and conditions that we have already discussed. So we have to just put it down over here. That for first one, it is sodium hydroxide aqueous and heat. For the second one, ammonia, ethanolic, and heat under pressure. And for the third one, sodium hydroxide ethanolic and heat under pressure. Sorry, here just heat or reflex. Is this clear to everyone?
सर रिएक्शन 1 और रिएक्शन 2 न्यूक्लियोफिलिक सब्स्टिट्यूशन कैसे है फिर से एक्सप्लेन कर सकते हैं?
See, I have given you the example when carbon is bonded to any group or any atom and that is replaced by any other atom, then it is nucleophilic substitution. And if you see, that's what is actually happening in reaction 1, that bromine is replaced by OH and bromine is replaced by is clear? Yes. Kumel. Yes, is this clear, Mahveen?
Yes, sir.
Okay. Just give me a minute, please. Okay. Now, have a look at this part. A sample of 2-iodopropane reacts under the same conditions as reaction 1 to produce this. Explain why 2-iodopropane reacts at a faster rate than 2-bromopropane. Yes, can anybody suggest the answer?
The carbon iodine bond is weaker than carbon and bromine.
Yes, very good, but it will get you a 1 mark.
आयोडीन की सर रिएक्टिविटी लोअर होती है.
But it's not iodine here. It is iodide. Okay.
जी सर.
So that would not be a second mark.
Iodide is easily oxidized. There's a stronger reducing.
No oxidation.
अच्छा हाँ सर.
Lower activation energy.
Okay, low activation energy we can write, but beside yes, right, but beside this, yes, but beside this, as we have mentioned that the bond is weaker. Whose mic is open? Just kindly unmute it. Okay. So carbon iodine bond is weaker than carbon chlorine bond because
So bromine है.
Yeah.
आयोडीन की नेगेटिविटी लो होगी.
Yes. Because iodine is bigger in size. So the attraction between the nucleus and bond pair in iodine is weaker than in bromine. Is this understandable? The explanation?
सर अगर हम साइज सीधा लिख लेते कि वो डिफरेंट पीरियड में, तो मतलब वो भी सेम ही बात होती ना.
Yes. But instead you can write that there are more shells in iodine than in bromine. Or you can instead write there is a high shielding effect. For the second mark, you can write that as Shahan said that there is a lower activation energy. Yes, obviously, because the bond, see, the bond is weaker, which means that it will be going to break at a lower energy. So there will be a lower activation energy as well. You can write that as well. Okay.
Yeah.
So is this part is understandable to everyone?
Yes.
तो सर डाउन द ग्रुप साइज बड़ा होता जाता है.
Yes, obviously, when you move down the group, there is always one electron shell that is added to the atom. Right? See, if you talk
Yes,
about
sir.
chlorine have a 2 shells, chlorine have a 3 shells, bromine have a 4 shells, and iodine have a 5 shells. So as the number of shells are getting more, the size would be getting bigger, and the valence electron is getting further away from the nucleus. So when the valence electron forms a bond by making a pair with the electron of another atom, that bond pair is obviously far from the nucleus in the bigger atoms. So that's why they are loosely bonded to the nucleus, or there is a lower attraction between the nucleus and that bond pair. So that's why it can be easily breakable, right?
Yes, sir.
Yes. If anyone have any other question, kindly ask. Okay. Now, figure 5.2 shows how butane 1-ol can be made from 1 bromopropane in 3 steps reaction. Okay. So see over here, if you see, this is your reactant and this is your product, right? And if you see in your reactant, how many carbon atoms are there?
3.
3. And in the product, how many carbon atoms are there?
4.
4. So it means we have added 1 more carbon. And if 1 more carbon is added, which clearly indicates that there is a 1 reaction in the series of a reaction where we have added a cyanide group. A nitrile group is being added. And if you see in the series of the reaction, you can easily figure it out. If you see over here, let me show you that this is a carbon, this is a carbon, and this is a carbon. And here you have a bromine. And if you look at the step 1, if you see that bromine turns into a cyanide, is replaced by cyanide, and now it becomes a nitrile having 4 carbon atoms. So this was a bromopropane or a 1 bromopropane, which actually turns into butane nitrile. And if you see that for this reaction, we need potassium cyanide, or instead potassium cyanide, we can use sodium cyanide as well. And again, this reaction occur in ethanolic medium. And for this reaction, heating is required. And if we look for the type of the reaction, this is nucleophilic substitution reaction. This is understandable to everyone? Yes?
Yes.
तो हमें ये specify करना होता है कि SN1 है या SN2?
No, if the examiner asks you, then you have to identify, specify whether it is SN1 or SN2. So for this reaction, if you see the halogenoalkane, the reactant, the bromopropane is a primary one, which means that it is actually SN2. So if the examiner asks you to specify through which reaction mechanism the product would form, then you have to specify that it would undergo SN1 mechanism or it would undergo SN2 mechanism. Okay.
Yes, sir.
Yes.
Okay. Now, if you look at step 2, in step 2, this is a nitrile, and the same carbon which is triply bonded to a nitrogen turns into a carboxylic acid. So in step 2, butane nitrile is turning into butanoic acid. If you recall the type of this reaction is hydrolysis. And for that hydrolysis, we can use any named acid like hydrochloric acid aqueous or sulfuric acid aqueous, or instead we can just use over here hydrogen ion and water like this as well. And again, we need to heat the reaction mixture to hydrolysis.
सर H plus के साथ H2O लिखना जरूरी होता है?
Yes, because H plus is always in the aqueous medium, then it's behave as a acid.
Right.
So you can use hydrochloric acid or you can use sulfuric acid as well. Now, if you go for a step 3, you see that in step 3, this carbon, that is a carboxylic acid carbon, is actually turns into a CH2 group, and as a result, butanoic acid turns into butane 1-ol, right? So the reaction in which a carboxylic acid turns into an acid, an alcohol, and carboxylic acid turning into an alcohol is a reduction. And this reduction, we always need lithium. The reducing agent that we use is LiAlH4, and it must be in dry ether. And again, we need to, heat the reaction mixture.
सर O हट के H आ गए तभी रिडक्शन है?
Yes. Yes. See, in organic, the reduction is of carboxylic acid, which turns into a alcohol. There is a reduction of a ketone, which turns into a, secondary alcohol. Yeah. Carboxylic acid turns into a primary alcohol on reduction. Ketone turns into a secondary alcohol on reduction. Nitrile turns into amine on reduction. And aldehyde also turns into a primary alcohol on reduction.
वो complete और incomplete का होता है ना?
नहीं, that is for oxidation.
Oh yes, sorry.
Now, in step 1, 1-bromopropane reacts with cyanide ion to form butane nitrile. That's what we have formed over here. Discuss. Complete figure 5.3 to show the mechanism for step 1. Include charges, dipoles, lone pairs of electrons, and curly arrows as appropriate. Okay. So see, these are the important things that you have to take care of while completing this mechanism. You have to include the charges, right? Charges means either positive charge or a negative charge. You have to put the dipoles, the partial positive and the partial negative. You have to put the lone pairs, and then you have to put the curly arrows wherever appropriate. And when they say curly arrow, so that arrow must be a curly, it is not like that a straight one. Okay. So let's start. That this carbon have a lone pair, and you see that here there is a bond between a carbon-carbon, right? Which means that this carbon is going to, attack this carbon. That's why you have to make a curly arrow over here. And as this carbon is bonded to a bromine, which is an electronegative element, that's make a dipole over here. This carbon must be partial positive and this bromine must be partial negative. Is this understandable to everyone?
Yes.
Okay. Now, when this carbon from its lone pair, the carbon of a cyanide approaches the partial positive carbon, at the same time, what would happen? That this bromine breaks this bond and takes away the whole pair of electron with it. As a result, it turns into a bromidine. And to that bromidine, you have to put a lone pair over here as well. Is this clear to everyone?
Yes.
Okay. Now, part 2. In step 2, butane nitrile is heated with HCl aqueous. See, that's what we have discussed over here in step 2. A hydrolysis reaction occurs. Construct an equation for this reaction in step 2. Okay, so we have to just write the equation. So we have butane nitrile. It is CH3, CH2, CH2, CH2CN, reacting with hydrochloric acid. So for the equation, you have to, as we have discussed earlier, what is our product for step 2?
Cyanide chloride से
form. The cyanide turns into carboxylic acid. So see, if I make this carboxylic acid, see, okay, 1 minute, did a mistake over here. It's a butane nitrile. So there must be 4 carbons. I have made 5 carbons, sorry. Okay. So it is reacting with hydrochloric acid. So that the last carbon, which have a triple bond with a nitrogen, that exact carbon is turned into carboxylic acid and the nitrogen is released. And that nitrogen in acidic medium turns into ammonium ion, NH4 positive. Is this clear? Yes.
Yes, sir.
Now, one thing, there are 2 oxygens over here, right? So, and there are no oxygens in any one of the reactants on the reactant side. So how we will balance these equation as the solution, as we are using the aqueous hydrochloric acid, right? So we will write a water over here to balance those oxygen, and there are 2 oxygen, so I would put a 2 over here. So the ammonium ion must be bonded with the chloride ion to actually forming its ammonium chloride, because here we have a HCl as well. So that would be your equation for the hydrolysis of a nitrile into carboxylic acid. Is this clear to everyone?
Yes.
सर आप NH4Cl चीज फिर से रिपीट कर दें.
Yes. Okay, actually what happens during this reaction, there is a carbon nitrogen triple bond, right?
Yes,
So
sir.
during this hydrolysis, basically this bond is broken and this carbon turns into carboxylic acid. Okay. And initially this nitrogen turns into ammonia. And if you recall, ammonia is an alkali, right?
Yes, sir.
And which medium we are using over here?
Acidic.
Acidic. So this ammonia formed reacts with HCl, and that's why our other product would be ammonium chloride. Is it clear now?
Yes, sir.
Okay. Now, step 3 is a reduction reaction. Okay, we just discussed construct an equation for the reduction reaction in step 3. Use atomic hydrogen to represent one atom of hydrogen from the reducing agent. Okay, so instead of reducing agent, you have to use this. And in step 3, the carboxylic acid that we have formed is actually turning into a primary alcohol. So here CH3, CH2, CH2, COOH, and then we use our atomic hydrogen over here. And what we know that the carboxylic acid is going to turn into an alcohol, right? So see, two hydrogens are removed from here. Sorry, two oxygens are actually removed from here. These two oxygens are actually going to form water. No, sorry, one oxygen is removed, one oxygen turns into alcohol, so water is formed. So if you see, if you compare the reactants and the products, what you will find over here, see how many hydrogens are over here? 7. And how many hydrogens are over here? No, sorry. Here you have 8 hydrogen. And how many hydrogens are over here? 12. So how many hydrogens are lesser on the reactant side? 4. So we would put 4 over here to balance those hydrogens. Is this clear?
Yes.
Yes. Next, state the identity of a suitable reducing agent in step 3. So in step 3, the carboxylic acid is actually reduced. So the reducing agent must be LiAlH4, and that must be in dry ether. Okay, so let me recall you, in your AS organic syllabus, basically there are 2 reducing agents. Okay, how many reducing agents are there? 2 reducing agents. One is LiAlH4, that must be used in dry ether, and the other reducing agent is NaBH4. So you need to remember that this actually LiAlH4 reduces aldehyde, it can reduce ketone, it can reduce nitrile, and it can reduce carboxylic acids as well, because it's a strong reducing agent. And NaBH4 is basically a weak or a mild reducing agent. Yes, very good. So it just reduces aldehyde and ketone only. So you have to remember these conditions. Is this clear to everyone?
Yes.
सर ऑक्सीडाइजिंग एजेंट्स कितने हैं?
There are two oxidizing agents in the similar way. Whenever there is a question for the oxidizing agent, I will make a list like this as well. There is a acidified magnate and there is a acidified dichromate that we normally use for our oxidizing agent. So acidified magnate can oxidize alkene, primary, secondary alcohols and aldehydes. And acidified dichromate can oxidizes only aldehyde and primary and secondary alcohols. Okay. Yes, is this clear to everyone?
Yes.
Okay. Now we are going to start the last question of this paper, that is question number 6. Okay. Here we are saying that Z is a molecule which contains the elements carbon, hydrogen, and oxygen only. Z contains only alkene and carboxyl functional group. Alkene means there must be a carbon-carbon double bond in the structure, and carboxyl means that there must be a COOH, carboxylic acid in the structure. Is this clear?
Yes.
Complete table 6.1 by describing the observations that occur when the two different reagents are added to separate samples of aqueous Z. So when we add bromine, bromine is of a orange color or a brown color. So that aqueous bromine on adding, the observation would be orange to colorless or brown to colorless. Okay. And actually, you have to remember this, that this observation is due to the presence of a carbon-carbon double bond in the structure. And when we add a sodium carbonate is a metal
सही है,
carbonate.
saturation test था ना bromine वाला?
Yes, unsaturation test. You are going to observe a bubbles and that bubbles of a carbon dioxide, and that is due to the presence of a COOH or carboxyl group in the compound. Is this understandable to everyone? Yes. Is this clear?
Yes.
Okay. Now, table 6.2 shows the percentage by mass of each element present in Z. Okay. Here we have carbon 41.38% by mass, hydrogen 3.45% by mass, and oxygen 55.17% by mass. Using the data in table 6.2, demonstrate that the empirical formula of Z is CHO. Show your working. Okay. So I think everyone knows how to find the empirical formula. So as carbon is 41.38%, so I have to divide it by its AR. Hydrogen is 3.45%, so I have to divide it its AR, which is 1. And oxygen is 55.1%, so I have to divide it by its AR, that is 16. So can anybody tell me the values, please?
Three 3.45.
3 point for carbon.
45. Yes.
सर तीनों की सेम है.
Okay, it's 3.45, and for oxygen it is also 3.45. So you see, we are getting the exact same value. So we would divide it by 3.45 because normally we divide it with the smallest one. So it is the smallest one. So we will get one.
अच्छा सर, जो smallest one होता है,
yes,
वो मतलब AR के रेशियो निकालने के बाद जो smallest आता है या
yes, yes.
मतलब
After dividing the AR, after dividing by the AR, the value we get, if then the value which is the smallest one will be divided with all the values. So here we are getting the value of 1, 1 and 1. So the empirical formula would be CHO. Is this clear?
Yes.
Okay. Now the mass spectrum question. Okay. Figure 6.1 shows the mass spectrum of Z. Okay. You see there are two values which are a very greater value of mass over charge ratio. That is 116 and 117. So what I can figure out from this, that 116 is M peak and 117 is M plus 1 peak because of a carbon 13, and this is all because of a carbon 12 isotopes. Is this clear? Yes, is this clear to everyone? You have to remember the two values which are on the extreme right, or the three signals which are on the extreme right, would help you to identify which peak is the M peak, which peak is the M plus 1 peak. For example, see, they have already mentioned that this compound have a carbon, hydrogen, and oxygen. But for example, if this compound have a chlorine in it, then if this compound have a chlorine in it, then you are getting a one more value over here of 118, and the ratio of the peaks of 116 and 118 would be 3:1 if there is a chlorine. Okay, but if there is a bromine in the molecule, for example, then at 118 you are getting another peak that is exactly equal to 116. So you are getting the two peaks, the M peak and the M plus 2 peak, with a 1:1 ratio, which is indicating that the compound have a bromine. But in this compound, there is no bromine or no chlorine, because they have already mentioned that their compound contains carbon, oxygen, and hydrogen. Okay. Now, what they are saying, deduce the molecular formula of Z. Explain your answer by referring to the molecular ion peak in 6.1 and the empirical formula of Z. So what they are telling you, that you have to use the molecular ion peak. Molecular ion peak is M with a positive charge peak, and the empirical formula of ZO. So how we would do that? That mass over charge of M plus peak is 116, indicating that MR, that is the relative molecular mass of Z, is 116. So if you go for the empirical formula mass, you have to find the empirical formula mass as well by to find the value of N. So empirical formula mass would be 12 plus 1 plus 16, because in empirical formula there is a CHO. It's just a CHO, right? So the empirical formula mass is 29. If you recall the expression for N, then N is basically relative molecular mass divided by empirical formula mass. So the MR of the compound is 116, and the empirical formula mass of a compound is 29. So can anybody divide me and tell me the value of N? Yes. Can anyone do the division and tell me the answer, please?
Here it's 4.
It's 4. So the molecular formula would be CHO times 4. So the molecular formula becomes C4H4O4. Is this clear? Yes, is it understandable to everyone? Yes, please. Now, in the next part, the part 2 of C of question number 6, use figure 6.1 to suggest the formula of the fragments with mass over peak charge peaks at 45 and 71. So it means the fragment that we are getting at mass over charge 45 would have a mass of 45, and the one which is at 71 would have a mass of 71, right? So we have to figure it out too. So actually they are talking about these two signals, that the peak which is getting at 45 m over e, and there is a fragment that have a mass over charge of 71, so that would be their masses as well. So we have to figure it out. Okay, so see, we got this empirical for molecular formula, right? Now, what functional group Z contains? Can anybody recall?
Carboxylic acid and ester.
No, not ester.
Alkene and carboxylic.
Carboxylic acid and alkene, right? Okay. So carboxylic acid is what functional group? COOH, right? So what is the mass of COOH? Can anybody count it?
45.
45. Is it 45?
Yes, sir.
So it means that the mass over charge 45, the fragment that is formed is basically COOH with a positive charge, because the positive ions are actually detected in mass spectroscopy. Okay. Now we have to find the fragment which have a mass of 71. So if I go for C, there are how many carbons in the whole molecule?
सर प्रोपीन बनेगा
No, there is no propene. How many
तो अभी
carbons
तो
is in the molecule?
टोटल ना तो एक कम हो
There are
जाएगा
total 4 carbons, right? And we are getting only 2 fragments. So it means if one fragment is COOH, then the other fragment doesn't have this COOH. So if I remove the COOH from the formula, I would get C3. I have removing one hydrogen, so there must be 3 hydrogen, and I am removing 2 oxygen, so there must be 2 oxygen. So can anybody find its MR? Is it equal to 71 or not?
यस सर
So it's 36 plus 3 plus 16, which gives me 71, right? So the mass over charge 71, the fragment which we are getting is C3H3O positive. Is this clear?
Sir, it's equal to 55.
Which is equals to 55. Okay.
Sir,
Sorry.
55.
2 oxygens, sorry. 2 oxygens are removed. So there must be 2 oxygen over here left. I just missed 1 oxygen. Now, so 32 plus 3 plus 36.
जी सर 71 ही आ रहा है सर मुझे पूछना था आपने ये कैसे बताया कि इस फॉर्मूला से कार्बोक्सिलिक एसिड और एल्कीन बनेगा
We know this from the start of the question, right? From these two observations, we have concluded, and they have actually told us that the Z can have these 2 functional groups. See over here.
अच्छा सही है सर समझ गई
Okay. Now, what they are saying, suggest the structure of Z using relevant information from table 6.1. Okay. B and C. Okay. So think from table 6.1, what information we have gathered, that there is a COOH and there is a carbon-carbon double bond, right? Beside this, we got its MR value, which is equals to 116. Third, we got its molecular formula, which is C4H4O4. Is this understandable to everyone?
सर कार्बन कार्बन डबल बॉन्ड का कैसे पता?
Beta, we have discussed 2 times. See over here, we are adding aqueous bromine in the Z and the C.
अच्छा हाँ सही सही इसमें
They
ओके
have
ओके
mentioned this, that it is only alkene. So that's why we, and if there is an alkene, then on adding bromine, it turns orange to colorless, and it is why, because it have a double bond, right?
सही है.
Okay. Now think, how many oxygens are there?
4.
First think, how many carbons are there? There are 4 carbons, right? So I would make up 4. There are 4 oxygens. Okay. In one carboxylic acid, how many oxygens are there?
2.
2.
2. So it means there is a chance of 2 carboxylic acid in a molecule, right? Is this point is clear?
यस सर अब एक कार्बन पे 2 H आ जाएंगे और
No.
एक
There is a
alkene
double bond as well. So for that double bond, these 2 carbons are left. So I would put a double bond over here. Now on those carbons where I have put a double bond, now those carbons have a 1 bond less. So there must be a hydrogen on those 2 carbons. Each carbon have a 1 hydrogen. Now if you see, we are getting 4 carbons, we are getting 4 hydrogens, and we are getting 4 oxygens, and we are actually covering that its molecular formula is this, its MR is this, it have a carbon-carbon double bond, and it have a carboxylic acid group as well. Is this clear?
यस सर.
Yes, if anyone have any confusion, any query, do ask, please. Okay, so we will be having a next session tomorrow, and I'm going to share the timing in the WhatsApp group. Okay, so see you soon tomorrow. Take care, everyone. Allah Hafiz.
वापस